Welcome to Digestion and Physiology, Series 3, Part 1, Fat Digestion. In Series 2, we looked at structural and non-structural carbohydrates. Now we're going to focus on a different source of energy, and that's fats. This section will be a little technical and scientific. To understand the importance of fats in the diet of horses, you need to get an idea of how fats are formed and digested. So firstly, what are fats? To provide a simplistic description, they are groups of fatty acids held together by a glycerol molecule. If there is one fatty acid attached to a glycerol molecule, then it is called a monoglyceride. If there are two fatty acids involved, then it is a diglyceride. And if there are three fatty acids, it is called a triglyceride. This last form of fat is the most common form found in feeds. Fat molecules are a string of these fats all joined together to form chains. These chains can vary in length from either short-chained fat molecules or long-chained fat molecules, depending on how many fats are involved. Fat molecules can be either saturated, like the white fat found around the outside of beef steaks, or unsaturated, like the oils used in cooking. The difference is in the chemical structure. If there are no what we call double bonds in the chemical structure, the fat is saturated, meaning nothing else can be added to the chemical structure. The result is solid, often white, fat. If there are double bonds present in the chemical structure, then it is an unsaturated fat, like cooking oil. The more double bonds there are, generally, the healthier the oil is, and the lower the melting point of the fat. For example, coconut oil, which is a saturated fat, melts when the temperature is at least 25 degrees Celsius. Olive oil is mostly a monounsaturated fat, meaning it has only one double bond in its chemical structure and turns into a liquid at -6 degrees Celsius. While canola oil, which is roughly a 50-50 mixture of monounsaturated and polyunsaturated fats, melts at about -11 degrees Celsius. Linseed or flaxseed oils, which is mostly polyunsaturated fats, is still in liquid form at -24 degrees Celsius. We talked in the previous series about non-structural carbohydrates being digested primarily in the small intestine, and the structural carbohydrates primarily digested in the hindgut. Fats are also primarily digested in the small intestine. In fact, you don't want too much making its way into the large intestine, as we'll discuss later. Fats are not digested in any way in the stomach, unlike other components of the feed. What happens in the stomach is that the fats congregate or clump together due to the burning effect of the acids, creating fat clumps or globules. And it's not until these fat globules make it into the small intestine that digestion starts. There are 4 distinct phases of fat digestion. Firstly, emulsification by bile salts, which I'll explain in the next slide. Then hydrolysis, which simply is the addition of water to help break down the fat globule into digestible molecules. The formation of mycel balls, which is small amounts of fat completely surrounded by bile salts. And then, finally, the fat is absorbed across the intestinal wall into the body. Digestion occurs primarily through a process called emulsification. It starts with bile salts being secreted into the small intestine via the pancreatic ducts from the pancreas. The bile salts have 2 sides to them. One side likes water, while the other side likes fats and hates water. The side that likes water is called hydrophilic, while the side that likes fats is called hydrophobic. The fat-liking side embeds itself into the fats, exposing the water-liking side. This water-liking side attracts water molecules in the small intestine, binding them to the outside of the fat globule. Water is a charged molecule, like most molecules, and, just like a magnet, when two similarly charged water molecules come near each other, they try to repel each other, pushing each other away. This causes the fat globules to tear apart into smaller pieces. Here is a good diagram, taken from a veterinary physiology textbook by Cunningham, 3rd edition, 2002. Fat globules leave the stomach and enter the duodenum. Here they get emulsified by the bile salts, pulling them apart in the jejunum. This whole emulsification process continues, breaking down the globules further and further until they are tiny molecules. When individual fat molecules, usually triglycerides, are surrounded by bile salts, a mycel ball is formed. At the end of the jejunum, the bile salts are removed from the triglyceride, allowing its transport through active transport across the intestinal wall into the body. The bile salts are reabsorbed through the ileum to be returned to the pancreatic duct and the whole process repeated. So, your take-home points are: fats are saturated or unsaturated. Fats and oils are digested in the small intestine, not the stomach. There are 4 phases of fat digestion. They are digested via a process of emulsification, hydrolysis, mycel ball formation, and absorption. Thank you for watching Equine Digestion Physiology Series 3, Part 1. If you like what you saw, please give us the thumbs up and share it with your friends. Connect to our website, our EQNC Facebook page and Instagram so as not to miss our next series.